Okay, so let's look at number 3. The problem is x squared minus 16x plus 64 is equal to 0. So let's see, let's find our x-intercepts first. That's one of the things I have to do. And I can find my x-intercepts by solving. And that means I can either use the quadratic formula or I can factor. Well, let's factor here because this one's not hard to factor. This is one of those easier factor problems that doesn't have a number in front of the x squared. So here's what I'm thinking. What do I multiply to get 64 that adds up to negative 16? And the answer is negative 8 times negative 8 gives me 64, and negative 8 plus negative 8 gives me negative 16. So it's x minus 8 times x minus 8 equals 0. Okay, notice both of these factors are exactly the same, so I don't need to write them down twice since they're two of the same thing. I just need to say x minus 8 is equal to 0. If I want to solve for x, I add 8 to each side, and I get x equal 8. Do you remember in class that we said if we only got one x-intercept, that means that it's our vertex? Because that means that if the only way to have one point on the line is if it's either your high point or your low point on your graph, and your high point or your low point is what your vertex ends up being. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Here's my vertex. This is going to be bad because it's going to go off the page, I'm afraid. Now, I know that when this happens, I'm probably going to have to find an extra point and make a little table of values, so we'll do that last. Let's see what else we get here. Okay, so I've got my vertex, I've got my x-intercept graph. There's only one of them. One of the other things I could do is do my y-intercept. That's an easy one. My y-intercept is just the constant on the end of the equation. So let me circle it in red. The constant on the end of the equation is 64. That means y is 64 when x is 0, or I could just say, oh, I go to the y-axis and I color in 64. Now, ooh, that's kind of fun, isn't it? Because I'm going to have to count by 1, 2, 3, 4, 5. Let me count by tens here. Let me try to make I wish I'd made my graph bigger. Each one of these things here is going to be 10. So 10, 20, 30, 40, 50, 68 will be up here. Okay. Now, so that's another thing. So we've got our x-intercepts, check. We got our y-intercepts, check. I need my vertex. Let's say I didn't realize that I'd already found my vertex because I didn't remember that when I only find one x-intercept that it's also the vertex. That equation is x equal negative b over 2a. Well, the b term is negative 16 up there. And then the a is the invisible 1, isn't it? That's what's going to help this problem a little bit. So negative 16 is a positive 16 divided by 2 is 8. So my vertex is 8. Now this is going to get kind of hard to graph because I counted by tens, but let me go ahead and put my, let's say it's about right here, okay? So that's my, I'm sorry, that's not right. If the vertex is 8, that's my x-coordinate. Ignore that last point. I don't know what I was thinking there. That means x is 8. I got to go get the y that goes with it. So let me go plug it in. X squared minus 16x plus 64 is equal to my y coordinates. If I put 8 in there and 8 in here, that's 64 minus 128 plus 64, which adds up to 0. So I have the point 8, 0. Oh, that's right there. Okay, so we see that our vertex was the same thing as our x-intercept, which we kind of can anticipate if we think about it. So let's see, I found my x-intercepts, my y-intercepts, my vertex. I still don't have a lot of good points because so many things ended up being the same. So now I could pick some points to plug in. One thing I can do is I can come through here and let me put in my axis of symmetry. Now you're going to have to imagine the other half of the graph because I didn't anticipate that this was going to have such a big y-intercept out there and such a big x-intercept. So if you think about it, here's what I'm talking about. I've got a point over here for my y-intercept. If I go the same distance on the other side of this red dotted line I drew, I'd have another point there. And I'm not going to see that in my graph. I could make a mini graph down here. Let's say this is 8, 0, and this is 64, 0. If I draw my axis of symmetry, if I've got something this far over this way, it'll be another point about that far over here. Okay? So that's what you're not seeing on that black graph, is that I can't go over the other side of that dotted line because I'm out of iPad space. So let me do something. Let's see if I want to find an easy point to graph. Really, I've already got 3. If I find one more point and graph it, then I can graph its buddy point on the other side of the x-axis, and I'd have 5 points. I'm going to choose a number that's easy. I'm going to choose 1. X is 1. So I'm going to say when x is 1, what's the y value going to be? Okay, so let me plug it into the equation up there. I go back to this equation up here that I just am circling in red again. It is x squared minus 16 times x plus 64. If I plug in 1, it's 1 minus 16 plus 64. 1 minus 16, let me just add the positives together. 1 and 64 makes 65, and then I subtract my 16, and 65 minus 16 would be 49. So if I'm going to graph the point 149, I'll graph it in black. 149, 10, 20, 30, 40, almost up to 50 would be about, let's say about right here, okay? So on this other little graph that I just did, it would be about right here. And if I have a point there on the same distance over on the other side, I'll have another point. So if you're looking at the little graphs, you can see the whole thing. It would be like this. The big graph, I'm only going to get half of it because I didn't make my scale big enough, or my graph big enough. So really, if you look at this is my graph here, that black U-shaped curve. Okay, so now we're going to do number 5. I'm going to go quickly because I'm almost out of room on this video. First thing I'm going to do, if you remember, there's 3 different things to do. Usually, one of them is find your x-intercepts and solve. So to find my x-intercepts, I set my equation equal to 0, which just means put y is equal to 0. And then I can either use the quadratic formula or factor. Now this one's easy to factor. It's x plus 2 times x plus 3. All right, so if I take each factor and I set it equal to 0, I get x equal negative 2 is one x-intercept. And on the other one, if I set x plus 3 equal to 0, subtract 3, x equal negative 3. My two x-intercepts are negative 2 and negative 3. I'm going to graph those in red. Negative 2 is here, negative 3 is there. They're really close together, aren't they? I'm going to go find my, let's see, the next thing I could do, I'll do it in a different color. Let's find our y-intercept. That one's easier. It's the number or the constant on the end, so it is this 6 up here. So if this is my x-axis and this is my y-axis, 1, 2, 3, 4, 5, 6, there's my y-intercept. So let's see, another thing I can do is find my vertex. I don't think this is going to be very pretty, but we'll see. Pretty sure it's not going to be pretty because it's got to be halfway in between those two x-intercepts. If you think about it, if you've got 2 points on the x-axis, the middle is probably going to be, you can probably predict that it's going to be negative 2.5 because my two x-intercepts are negative 2 and negative 3, so it's got to be halfway in between that. But let's do it with the formula. Negative b over 2a. b is 5. A is 1 above. Remember the invisible 1. I'll write it in purple. So that's negative 5 over 2, and sure enough, that is negative 2.5. So if I want to find, so I know my vertex is at negative 2.5, and now I got to find the y that goes with it. So let me go back to the equation up there. X squared plus 5x plus 6 would give me my y value. So I'm going to plug in negative 2.5, which is this number right here that I just found from that little formula. It's going to be hard to write it in there, so hopefully you're listening, and we're just kind of rolling with it, both visually and auditorily. 2.5, negative 2.5 squared is 6.25, and it's positive because we squared the negative. 2.5 times negative 2.5 times 5 is negative 12.5 plus 6. So let's add those up. 6.25 minus 12.5 plus 6 gives me negative 0.25. So my vertex is negative 2.5, negative 0.25. So let me graph that in orange. Negative 2.5 is halfway in between negative 2 and 3, and it's just going to be slightly, it's going to be a fourth of the way between 0 and 1. Now, since I've got my vertex now, let me draw in my axis of symmetry, because that can at least help me get the last point I need to graph. I'm going to change to blue, because if you look up at my y-intercept, it is 2.5 from this middle line, isn't it? So if I go 2.5 the other way, it'll be about, let's say about right here. That's a stray line there that's kind of going horizontally across the page. Let me draw my graph now. I'm going to draw it in red just so you can see what part's really the graph and what's the extra stray mark here. So I'm going to go to the vertex, make a U shape, there's my graph. So just because it's a decimal doesn't mean that it's anything any differently. You just got to get used to the fact that sometimes numbers don't fall right on your little square marks and you just approximate where they are.